Hi, welcome to Bald Spot Math. Today we're going to focus on finding the area of parallelograms. Of course, we've already discussed rectangles and squares, which are parallelograms, but they're not always in the shape of a rectangle or square. So what do we do when we've got a parallelogram? We need to find its area, and it's not a rectangle or square. Let's take a look. All right. So we're going to use what we know about rectangles and finding the area of rectangles to help us find the area of a parallelogram. So I've got a parallelogram here. Clearly, it does not look like a rectangle or square. But we can use what we know. And we can break this shape apart, which is called decompose. And then we can put it back together in a different way, which is called compose. So we're going to break it, then we're going to put it back together, but it's going to look very different when we're done to help us see how this works. So in order to decompose this, what I'm going to do is I've got another triangle here, which fits this area here. So I'm going to break this off. All right, so what I've got to do, and this is going to be a little bit messy, is I'm going to get rid of that. Okay? But this part that I just got rid of, it's over here, and oops. Wait a minute. That's what I want to move. And I'm going to move this here. And now what have I formed? An ugly rectangle. I mean, if I was doing this on paper, it would look a little bit better. But I've got a rectangle here. You can see it. So by taking part of the parallelogram off, moving it over here, I've constructed a rectangle. And we know the formula for the area of a rectangle is either A equals base times height, and we've talked about it's also A equals length times width. So if I knew the dimensions of this base and this height, I would then be able to calculate the area of the rectangle, which is the same as the area of the parallelogram, because remember, all I did was move that from over there. So let's apply this further. Okay, we're going to apply what we just learned about how we can use base times height to this example here. We've got base is equal to 10. We've got height equal to 3. How do we know it's the height? Because it's perpendicular to the base. Remember, earlier I moved this triangle over here. So we knew that was the height. This line here is equal to this line. It is the height of the parallelogram. I know to find my area, it's still base times height or length times width. I plug in 3 times 10 and I get 30 square units or units squared. That's it for today.